Artificial intelligence is no longer just an academic discipline or the subject of science fiction. It is now a fundamental force shaping how we work, communicate, learn, and even make decisions. But as AI becomes more powerful and embedded into daily life, one question becomes increasingly urgent. What are the ethics behind AI development? At the heart of this question lies a paradox. AI is created by humans to serve human interests, but it can also replicate or even amplify our flaws, biases, and blind spots. The choices we make in designing, training, and deploying AI systems can have far-reaching consequences. And unlike traditional software, AI doesn't just follow instructions. It learns, adapts, and sometimes surprises us. This is why AI ethics isn't a footnote. It's the foundation. Let's begin with one of the most talked about concerns: bias and fairness. AI systems are only as good as the data they are trained on. If that data contains historical prejudices, social inequalities, or cultural blind spots, the AI will learn them. In hiring algorithms, facial recognition, loan approvals, and even criminal sentencing, biased AI has already led to real-world harm. For example, studies have shown that facial recognition systems perform less accurately on people with darker skin tones. Language models may reproduce sexist or racist stereotypes if their training data includes biased content. These aren't just technical bugs, they are ethical failures. Fairness in AI means more than removing explicit bias. It means actively auditing data, defining what fairness means in each context, and involving diverse stakeholders in system design. Next is the issue of transparency and explainability. Many modern AI models, especially deep learning systems like GPT-4, are considered black boxes. They produce impressive results, but it's often unclear how they arrive at their conclusions. This opacity makes it difficult to trust or verify decisions, especially in high-stakes areas like healthcare or criminal justice. Explainability means creating systems where humans can understand the logic, or at least the inputs and assumptions, behind AI decisions. It's not enough for an AI to be right. We need to know why it's right. Then there's accountability. When an AI system makes a mistake, who is responsible? The developer, the user, the company that deployed it? Traditional liability frameworks don't easily apply to autonomous systems. If a self-driving car crashes or an AI medical tool gives a harmful diagnosis, legal and ethical questions quickly arise. That's why AI governance frameworks are now emerging to define responsibility, set boundaries, and ensure redress mechanisms are in place. A related issue is autonomy and consent. As AI systems become more persuasive, generating human-like text, speech, and images, users may not even realize they're interacting with a machine. This blurs the lines of informed consent. Should users be notified when content is AI-generated? Should they have the option to opt out of AI interactions? Autonomy also applies to surveillance. AI is widely used in monitoring tools, from workplace analytics to national surveillance systems. The ethical question is not just, can we do it, but should we do it, and under what conditions? Another central theme is privacy. AI thrives on data, but data is often personal, sensitive, and vulnerable to misuse. Models trained on user interactions, health records, or conversations can inadvertently expose private information. Even anonymized datasets can be re-identified with enough effort. This raises concerns about how data is collected, stored, and used. Are users giving informed consent? Are companies transparent about data practices? Are there limits on what can be inferred? Global regulations like the GDPR and China's PIPL attempt to address these issues. But laws often lag behind technological capabilities. Now let's talk about misuse and malicious applications. AI can be weaponized. Deepfakes can create fake political videos. Generative models can automate disinformation. Autonomous drones can be turned into lethal weapons. The dual-use nature of AI, its ability to help or harm, makes ethical foresight critical. Tech companies now face a responsibility similar to that of pharmaceutical or weapons manufacturers, anticipating how their creations might be abused and building safeguards proactively. OpenAI, for instance, introduced safety filters, usage restrictions, and staged releases for its models. But enforcement and global coordination remain challenging. The ethical debate, it also extends to labor and displacement. As AI automates more tasks, writing, coding, diagnosing, analyzing, entire job categories may be reshaped or eliminated. Who benefits from this efficiency, and who is left behind? Ethical AI must account for economic transitions. This includes supporting workforce reskilling, creating safety nets, and ensuring that the productivity gains of AI are shared, not hoarded by a few. Some thinkers argue that power asymmetry is the root of many AI ethics problems. If only a handful of companies or governments control the most powerful AI systems, they can shape narratives, influence economies, and even manipulate populations. Decentralization, open source alternatives, and transparency in model development are proposed counterweights. Then we arrive at just long-term concerns, such as the path to artificial general intelligence. As AI grows more capable, the risks become more abstract, but more profound. What if we lose control of systems we don't fully understand? How do we ensure alignment between machine goals and human values? Organizations like the Alignment Research Center, DeepMind's safety team, and OpenAI's Alignment Division are exploring these questions. But we're still at the early stages. Philosophers, ethicists, policymakers, and engineers must collaborate to prepare for this future. So where do we go from here? The ethics behind AI development cannot be solved by one model, one company, or one regulation. It requires a culture, a shared commitment to responsible design, inclusive processes, and ongoing vigilance. Here are a few guiding principles. Chapter 1. Do no harm. Minimize unintended consequences through testing, red teaming, and user feedback. 2. Design for fairness. Include diverse perspectives, datasets, and definitions of equity. 3. Be transparent. Let users know when they're interacting with AI and how it works. 4. Protect privacy. Limit data collection, anonymize where possible, and respect user consent. 5. Build in accountability. Create clear chains of responsibility and avenues for redress. 6. Foster global cooperation. Work across borders and sectors to create aligned standards. Ethical AI isn't a checklist, it's a discipline. It evolves as our understanding grows. It requires humility, dialogue, and continuous learning. As AI becomes more embedded into the systems that shape our lives, from healthcare to hiring to justice, we must ensure those systems reflect not just intelligence, but integrity. Because in the end, the question isn't just what AI can do, it's what we as a society that choose to do with it. Around the world, different regions are approaching AI ethics with unique frameworks. The European Union is leading the way in regulatory clarity. Its proposed AI Act classifies AI systems by risk level, banning some, heavily regulating others, and requiring transparency across the board. High-risk AI, such as biometric surveillance or systems affecting civil liberties, must meet strict standards before deployment. Meanwhile, the United States has taken a more fragmented approach. Federal agencies issue guidelines, but no comprehensive national AI law exists yet. However, the Biden administration has released an AI Bill of Rights, laying out core protections like the right to know when AI is used and the right to opt out. In China, ethics is intertwined with state priorities. AI is seen as a driver of national development, but content controls and surveillance capabilities are built into many systems by design. The government has introduced rules on algorithmic transparency, especially for recommendation engines and content moderation, but always through a national security lens. This diversity of approaches creates a complex global ecosystem. On one hand, it allows experimentation. On the other, it risks fragmentation. Without international consensus, we may see AI nationalism, where ethical standards diverge along political and cultural lines. That's why many experts advocate for global institutions to oversee AI, akin to the UN or the WHO. These could help set norms, resolve disputes, and ensure that AI development remains aligned with humanity's shared values. Academic institutions are also playing a growing role. Ethics curricula are now being integrated into computer science and data science programs. Tech conferences routinely include ethics tracks. A new generation of researchers is being trained not just in how to build AI, but how to question its implications. Tech companies, under pressure from users and regulators, are also adapting. Google created its AI principles after employee protests over military contracts. Meta has released transparency reports and red-teamed its LLMs. Microsoft is embedding responsible AI into its entire development lifecycle. OpenAI has gone further, creating an external oversight board and funding alignment research. Still, skeptics warn that ethics washing is very real. Companies may publish lofty guidelines without changing core practices. Ethics must be embedded in incentives, not just public relations. One emerging solution is participatory design. Instead of building AI in isolation, developers involve affected communities